is a question and answers for clipper circuit. There is a numericals I have included for the clipper circuit. We have already done 2 parts for that is covering the theory part of clippers. Today in this video we will be doing the questions. Okay. So the first question is this: what is the peak value of output for given input? So we are being given a waveform like this. This is a triangular waveform. So we need to find what is the peak value of output. So a circuit is being given. We are going to apply this input to this circuit. So this VI is being given to this circuit. Here we are not considering the ideal, that is the practical diode case. We are not considering. We are just considering that this is an ideal diode. So we will be just taking this waveform and applying to this circuit, and we will be seeing what is the output. Here if you see, there is a resistor in series and a diode is connected in parallel along with a voltage source. So this diode is connected in parallel. So it is a first understand that this is a clipper circuit. Okay, so if it was a clamper circuit, I'm just giving you a trick. If it is a clamper circuit, it will be having a capacitor. Here there is only a diode, resistor and a voltage source. So this can be a clipper circuit. Okay, so here in this question, this is a clipper circuit. The diode is connected in parallel, so it is a shunt clipper, and the diode is connected in such a way that negative is facing towards the up and then the anode. So it is a negative peak shunt clipper. That is, this clipper is used for clipping of the negative half cycle. Okay, so we have discussed all these things in detail in the theory part. Anyway, first you have to identify what type of clipper is that. Only then you can find what is the output waveform, right? So this is a negative shunt clipper. That is negative peak clipping shunt clipper it is. And a voltage source is connected. So it is a biased clipper. The voltage source applied is a positive bias. Okay, so this is actually a negative peak shunt clipper with positive bias voltage. Okay, so this circuit is actually designed to clip off your negative half cycle, and it will be passing the positive half cycle, but consider that there is a bias voltage here. So what will happen during the positive half cycle? Now let us see the working. During the positive half cycle, this positive half cycle is coming to the input side. The diode is connected in such a way that this positive half cycle is trying to make the diode reverse bias. But see the voltage source, it is making the diode forward bias. So what will happen during the when the diode is connected in parallel case? Our favorable condition is that we need a reverse bias to get our output or Vout. So that is our favorable case. So here actually the input is trying to make the diode reverse bias itself, but due to this voltage source, it can only make the diode as forward bias if Vi is greater than 4 volt. This is the case. This is the condition. So when Vi is greater than 4 volt, the diode will get a reverse bias, and due to the since the diode is connected in parallel connection, when it is a reverse bias, you will get whatever is in Vi to the V outside. So your waveform will look like this. This is the waveform. This is a 4 volt. The peak value will be, see, from 4 volt onwards, the diode will get reverse bias. So we will get our output or the values from 4 volt onwards, we will be getting towards the output side. So it can go up to how much? 16 volt. From 4 volt onwards to 16 volt, it can go up. Again, when the waveform is dropping till 4, we will get output. After 4, if it is going below, we won't get the output. That is the case. So this is your output waveform. I hope it is clear. Okay, so the output waveform's peak value will go up to 16 volt is your correct answer. So in order to answer such questions, first you have to identify what sort of a clipper is that. Then you have to find out how the clipper is going to work, which part is it going to clip off, and how the clipping is actually done. So first understand that there is a negative peak shunt clipper with a positive bias voltage. So it will clip off the negative half, but also the positive half it will be passing with the bias voltage. That is from 4 volt only it will pass the input to the output side. Okay. The next question is this. Sketch output waveform of circuit. Consider diode as silicon diode. So this we are going to consider this as a practical diode. So earlier we have not considered this as any diode, that is silicon or germanium diode. Just a ideal diode we have considered. But here they have been specifically given that this is a silicon diode. So we have to consider it as practical diode. Now what is the difference? I'll explain while explaining the question. Okay, so here first identify what sort of a circuit this is. So this is a clipper circuit and it is a series clipper and it is used for clipping of that is it is connected in negative and positive. So it is used for clipping of the positive half cycle. So it is a positive peak series clipper circuit. Okay. Also, there is a voltage connected to the input side, that is in front of the diode there is a 2 volt connected, right? Now, let us see how the circuit is going to work. Okay. So anyway, it is going to clip off your positive peak. Okay. So what will happen during the positive half cycle? See, during the positive half cycle is coming, the diode is connected in such a way that negative and then positive. So it will get reverse bias, and also if you see this voltage source, it is connected in such a way that it is making the diode as reverse bias. So, that is due to the input waveform Vi also, and due to the output and due to the voltage connected in front also, the diode is getting reverse bias during the positive half cycle. So you won't get any positive half cycle. See here, there is no positive half cycle. Okay, next, let this be T by 2. Okay, so till T by 2, there won't be any output waveform. The waveform will be completely clipped off. Next, from the T by 2, that is during the negative half cycle, what is happening? During the negative half cycle, see this negative half cycle is coming as the input to this circuit. Let us consider that. This negative half cycle is trying to make the diode as forward biased, right? But we know that since it is a practical diode, when the diode is in forward bias condition, it is acting as a what? It is acting as a symbol voltage cell. So I have explained this in many of my videos that when diode is working or when the diode is in forward bias, it acts as a voltage cell or a source. When the diode is in, this is in forward bias. When the diode is in reverse bias, it is acting just as an open circuit. That is why we are not getting any output. So here, during the forward bias condition, it is acting as a voltage cell. Now, what is the value of this voltage cell or voltage source? It is equal to 0.7 volt. Since it is given that it is a silicon diode, the voltage drop across the PN junction of the diode is equal to 0.7. So that is the difference between silicon diode and germanium diode. Anyway, both diodes are just PN junctions. Whenever the PN junction has to be forward biased, there is some voltage getting dropped across the junction to break the barrier. So that is a very basic of diodes. So it is equal to 0.7 for a silicon diode. It's been given that silicon diode is being used. So it is a 0.7. Now that is the case. Okay. So what is the effective voltage coming to the output side? So here it is a Vi is coming. So what is the value of Vi coming? It is minus 5 volt. Okay. So try to apply a KVL in this loop. So it is write the equation for KVL. So minus 5 plus 2 plus 0.7 plus V out. That is V out is taken across the load resistor. So equal to 0. So you'll be getting V out is equal to minus V out is equal to 0. So V out is obtained as minus 2.3 volt. Okay. So this is plus and minus. So it is a minus V out. So if you solve this equation, you will get V out equal to minus 2.3 volt. Okay, so what is the value of V out coming at the output side? It is minus 2.3. Again, the positive half cycle is clipped. Minus 2.3 volt is your value for negative peak. Okay, dotted lines. Okay, this is minus 2.3 volt and this is your output waveform. I hope this KVL application is clear. See, here I am going to apply a VI to the circuit. So the VI coming to the circuit is now negative half cycle. So it is a minus 5. Then there is a 2 volt here. There is a 0.7 volt due to the forward bias of the diode. That is a voltage drop. Again, V out is being taken across this load resistor. And we know that since we are taking the current flow in this direction, it is a plus minus. So if you write the equation, it will be minus 5 plus 2 plus 0.7 minus V out is equal to 0. And if you solve it, you will get it as minus 2.3 volt and that is the value of your peak negative of your output waveform. So this is how your output waveform will look like. Find the output waveform for the circuit. Consider silicon diode is being used. So we have to go for a practical diode approach to do this problem. So the input waveform is a sine wave having plus 20s Vmax and minus 20s Vminimum. So we have already discussed such a circuit. It is called a dual clipper. It is used for clipping of both the positive and the negative half cycle. I've explained about this in detail in my theory video. That is 2 parts of clipper theory we have uploaded. So in the part 2 we have discussed about the dual clipper. This is a dual clipper. Okay. So what will happen during the positive half cycle? During the positive half cycle, this positive half cycle of the VI or input voltage is trying to make the diode forward bias. But since the diode is in parallel or shunt connection, what will happen? The VI is actually when it is making the diode as forward bias. When the diode is forward bias means it will go to the ground. Okay. So, but if you see this voltage applied here, the positive side of the voltage source is connected to the negative terminal of the diode. So, this voltage source is making the diode as reverse bias. Okay. So, when this branch or when this diode is in forward bias condition, what is the total voltage coming across this branch? So, there is a diode here. This is the diode and there is a plus 5 voltage source, right? So, what is the total voltage coming when the diode is getting forward bias? So, we have already discussed that when the diode is forward bias, it acts as a voltage cell. When the diode is in a reverse bias condition, it acts as an open circuit. Simple, right? So, during forward bias condition, we can replace this diode with a voltage source. Okay. So, the total voltage across is 5 volt plus the built-in potential, that is the barrier needed to make the diode conduct in forward bias condition. Since it is given that the diode is a silicon diode, this voltage is equal to 0.7. Right. So, the total voltage coming across this branch during the forward bias condition is actually 5 plus 0.7 volt. That is 5.7 volt is the total voltage coming across the branch during the forward bias condition. So, this much of voltage is needed to in order to make the diode as forward bias condition, or VI should be greater than 5.7 to make the diode as forward bias condition. Till that, the diode will be in reverse bias condition. That is the case. Okay. So, this much of voltage is actually needed to make the diode in forward bias condition, or VI should be greater than 5.7. 5.7 is needed to break the barrier of the PN junction or the diode junction. Also 5 volt, since it is in reverse bias condition, we need that much of voltage also. So total 5.7 or VI should be greater than 5.7. Okay. So how will the output waveform's positive half cycle look like? During the positive half cycle, if the voltage is greater than 5.7, that will be clipped off. Okay, so we won't be getting the minus 20 volt. It will get clipped off because if the voltage is getting greater than 5.7 means the diode is now forward biased and it will get to the ground. Okay, so that is the waveform during the positive half cycle. Now during the negative half cycle, what is happening? So during the negative half cycle, what is happening? This VI is trying to make the diode as forward bias, but this 10 volt is connected in such a way that it is making the diode as reverse bias. So again, the total voltage coming during the forward bias condition of the diode is 0.7 plus a 10 volt. So this is a 10 volt, this is a 0.7. So total voltage coming across this branch during the forward bias condition of the diode is 10 plus 0.7, that is 10.7. Okay, so total 10.7 volt is coming. But when VI is greater than 10.7 only, the diode will get forward bias. Till that, due to the presence of this VI, it is reverse bias. Okay, so we have to make VI greater than 10.7 for the diode to actually be forward bias, because there is a 10 volt barrier voltage and also 10 volt voltage source which is making the diode reverse bias, and also there is a barrier potential of 0.7, right? So total 10.7 voltage is there, and we have to apply a VI greater than 10.7 to actually make the diode as forward bias. So when it is greater than 10.7 means the diode will start conducting and the output will go to the ground. So the output waveform during the negative half cycle will look like this. It will be equal to minus 10.7. Till minus 10.7 you will get your output. But after the voltage VI applied is greater than 10.7, the diode will start conducting and clipping will take place. So this is how your output waveform will look like. Okay. So this is a dual clipper, and the output waveform for this particular circuit is like this. The positive half cycle is also clipped and negative half cycle is also clipped. So this is the case when we are considering the diode in practical consideration. During when we consider that the diode is ideal, we don't take this barrier potential, we just take the voltage applied, that is a bias voltage applied. Okay, but if in the question it is given that it is a particular type of diode, or you have to take the practical consideration, means you have to consider the built-in potential also. Okay, so this is the answer for this question. The next question is this: draw the output of the circuit, consider silicon diode. So there is a triangular waveform given to the circuit. So this is actually a clipper circuit, and it is used for clipping of the negative half cycle. Okay, so this is a negative shunt clipper circuit with a bias voltage of 5 volt. Okay, so what will happen during the positive half cycle? This positive half cycle is actually trying to make the diode as reverse bias. See, this is a positive half cycle coming to the input side, and the diode is connected in such a way that negative is connected to the top and then positive side, or anode, cathode then anode. So this VI will try to make the diode as reverse bias. Okay, now when the diode is in forward bias, first let us consider what is the total voltage coming across this branch. So the diode is connected in negative, positive, likewise. So during forward bias the voltage will be like this, and this is connected 5, positive and negative. So this is 5 volt. So what will be the voltage here? It is given that consider silicon diode. So it is a 0.7 volt, right? Now see the connection of these two voltage sources. It is in opposite polarity. So what is the total voltage coming in this branch? It is 5 minus 0.7, which is equal to 4.3 volt is coming. Okay, so this branch is having 4.3 volt during the forward bias condition of this diode. Okay, so even though VI is trying to make the diode as reverse bias, and reverse bias condition is a favorable condition during the shunt connection, VI should be greater than 4.3 volt in order to make the diode actually reverse bias, so that we will get our output. So your output waveform during the positive half cycle will look like this. It should be starting from 4.3 volt, then going up to plus 20. Okay, We'll draw it little neatly. That is from 4.3 starting onwards to 40, then up to 4.3 it will conduct. Okay, this is plus 20. The peak value will be up to plus 20. And what will happen during the negative half cycle? During the negative half cycle, the diode is forward biased by VI, and also this 5 volt is connected in such a way that it is also making the diode as forward biased. So the output waveform will look like this. This is your output waveform for this particular clipper. Okay, so these are the questions which I have included in this video. I hope that this video was useful for your preparation. If yes, please do give it a thumbs up and also share this video with all your friends. Clippers are very much important if you're going for competitive examinations. There will be clipper circuits given to you, and you have to identify the output waveforms from the option, or you have to identify what sort of a clipper is that. So anyway, these clipper circuits are very much important. So if you want more videos, please do subscribe to the channel also, and also share this video with maximum of your friends. Thanks for watching and keep on watching.